Hello everyone, good morning. Welcome to this class. So we have already studied that Newton's first law of motion. According to Newton's first law of motion, we can see that if you are not applying any unbalanced force to the object, then the object will not change its state. It will be continue to be in the state of rest, otherwise in uniform motion. Now whatever the example that I have taken over here, there is a glass which is full of water and there a coin is placed on a piece of paper. Now when suddenly I'm just removing the paper, then what happened that the coin that was placed on the paper that get inserted into the glass. Now in this case we can say whenever you are suddenly removing the paper, that means you are applying some unbalanced force. After the application of the unbalanced force, the coin still want to be in the state of rest. So that's why it just fall down. Whenever you are removing the paper, the coin has not just gone out with the paper. It just remain in the state of rest. So that's why it just fall down into the glass. So there is a concept that each and every object has a tendency to resist the change of its state, right? Or motion. Suppose a body can be in the state of rest, otherwise in the state of motion. So whenever you are applying the unbalanced force, the body can be a living or it can be a non-living object. It should have a tendency to resist the change of its state. Okay, this property is known as inertia. Inertia, you can say it is depending on the mass of the object. More the mass of the object will be, more will be the inertia. Okay, suppose if there is a man who is just standing on a bus and suddenly the bus starts. Now, if the mass of the man is less, now whatever the backward force he feels, that will be less. But if the mass of the man is greater, then the backward force felt by him, that will be greater. So the inertia that is only depending on the mass of the object. And this Newton's first law of motion, it is known as law of inertia. Now up to that portion, if you have any of the doubt, you can tell me in the WhatsApp group that we have made. Okay, now today we'll just study that what is momentum, what is Newton's second law of motion, and what are the types of inertia. I'm just going to revise for you people, because in these days I hope you have already forgot that what are the types of inertia and what are their properties, what are the different examples can be taken to illustrate them. So I'm just starting that one. The first, the type of inertia, that is inertia of rest. In the inertia of rest, what I have just told you, that whenever an object is in the state of rest, now look at the picture, there is an egg which is placed on the top of a substance. Now it is in the state of rest, right? Now whenever you are applying some unbalanced force, suppose I'm just removing the object on which it is placed. Suppose if this is a glass, we can say if this is a glass, so on the glass the egg is placed. Suddenly if I just remove the glass, then what will happen? The egg will fall down on the plate and it will be broken. But why it is happening? Because the egg was initially in the state of rest. Whenever you are suddenly removing the glass, it want to remain in the state of rest. That is the property of the object, that is known as inertia of rest. That means whenever some external unbalanced force is applied, then the object is having some tendency to remain in the same state. Now in this case the object is in the state of rest. After the application of the unbalanced force, it will try to remain in the state of rest. Now the example we can take that we are supposed to stand on a bus and suddenly the bus starts. Then what will happen? We'll obviously feel a backward force. Why we are feeling that? Because initially we were in the state of rest. After the application of the unbalanced force, that means whenever the bus starts suddenly, then in that case the inertia of our body wants that we should be in the state of rest. but the bus had already started, right? So that's why our feet is in motion, which is in touch with the bus, but the rest of the body that become unbalanced. So that's why we feel a backward force, and sometimes we also fell down. Okay, so that is the inertia of rest. That means a property by which it resists the change of its state. Okay, the best thing to remember the inertia of rest, inertia of motion, inertia of direction. That means whenever you have to explain that thing, inertia of rest means the body is initially in the rest position. Okay, and you are applying some unbalanced force, so that's why it is feeling a backward force. That is the inertia of rest. Why I am repeating this concept, that you can remember it well. Okay, now inertia of motion. Inertia of motion is same. That means you are initially in motion. Suppose you are just running so fast and suddenly you can't stop, right? If you suddenly stop, then what will happen? You will feel a force in the forward direction. So we are just assuming that you are just traveling in a bus and suddenly the bus applies brakes. And whenever the brake is applied suddenly, you will just feel a force in the forward direction. So why I am feeling this? Because I was in the state of motion. Suddenly some unbalanced force was applied. That means suddenly the bus stopped. So that's why I'm not able to balance the total weight of my body and I just fall in the forward direction. Right? That things I hope already happened to maximum of the people, right? You can understand this thing whenever you have actually felt that. Okay. Now, inertia of direction. Inertia of direction we have already explained in the class that it is the tendency that to oppose any change in the direction. Suppose you are just traveling by car and you know very well what the hillside roads are. And whenever they are just taking a turn, you are just feeling a jerk in the opposite direction. Suppose it is taking a right turn, then you are just feeling a jerk in the left direction. This is due to the inertia of direction. That means our body will resist the change of its direction also. Every body, not only our body, we can say, every living and non-living object is having the tendency to remain in the same state. If I am in the state of motion, I want to be in the motion. If I am in the state of rest, I want to be in the state of rest. I don't want a change. That is the inertia. Okay, that resist the change in the state of an object. Now, till that time, if you are having any confusion, any doubt, you just give me a reply in the WhatsApp group. I will just make you understand again. Now, linear momentum. So, linear momentum. There are two kinds of momentums. One is linear momentum, and other is angular momentum. Angular momentum you will study in class 11. In class 11, the same chapters are Newton's laws of motion, even the gravitation, sound. Every chapters are same in class 11. You will just study these chapters again there. Now, linear momentum means what? A momentum which is a linear, right? That means whenever an object is moving with some velocity of v, that meter per second, and if the object is having a mass of m, then the linear momentum is defined by p, and it is equals to the product of mass and velocity, right? So suppose you are just traveling by a car, or you are just traveling by a cycle. So in that case, if you are having some velocity of v and if you are having a mass of m, then your linear momentum will be the product of mass and velocity. Okay. Now, there are some properties. I hope you guys required the notes, so that's why I have just written each and every point. Now, on the P, there is a sign that is given here. This sign is actually the vector sign. Okay, just remember that thing. That linear momentum is a vector quantity. Why I am saying it's a vector quantity? Because it is a product of mass and velocity, and velocity is a vector quantity. Mass is obviously a scalar quantity. It is just having the magnitude and it does not having any direction. but the velocity, it's a vector quantity, right? So that's why the momentum is defined as P vector equals to mass multiplied by V vector. It is the correct expression. Okay, there should be another arrow that should be placed over here. By the typing mistake, I did not have placed that arrow, but an arrow should be there. If any quantity is vector, so that arrow sign should be given on that. For the scalar quantities, we do not have to place any sign over the letters. So the linear momentum is having the magnitude, that is the product of mass and velocity, and it is having the direction in the same direction of the velocity. If the object is having the velocity in the north direction, so obviously the momentum is having the direction in the north, the same direction like the velocity. Now what is the unit? We'll discuss about the CGS and SI unit of momentum. Now in this case, the CGS unit of mass, that is of gram, the CGS unit of velocity, that is of centimeter per second. So CGS unit of momentum, that is of gram centimeter per second. Now SI unit, this is the CGS unit, okay, and now this is the SI unit. To study the SI unit, what is the SI unit of mass? That is of kg. The SI unit of velocity, that is of meter per second. So the SI unit of momentum, that is of kilogram meter per second. Okay. Now on the basis of momentum, some of the questions are asked which are of 1 marks or 2 marks. I will just make separate video on the numerical questions. Okay. Now till that time, I hope you have understood what is momentum. It is actually a vector quantity. It is a product of mass and velocity, and it is having the direction in the same direction of the velocity. Okay. Now the next thing, that is of Newton's second law. Newton's second law is very much important because it is related with each and everything. That means whenever an object is applied with some unbalanced force, so the object is changing its state. So suppose it should have some velocity, there will be a change in momentum, the body will be accelerated. So there is a relation that is established by Newton's second law. Now suppose there is an object which is having a mass of m and it is having two wheels also. You are applying some unbalanced force. That object was initially in motion and it was having an initial velocity of u meter per second. Okay, the object was initially having a velocity of u meter per second. After the application of the unbalanced force, that means you are accelerating the object. The speed of the object that is getting changed, and now the object is having the velocity of v meter per second, right? The mass of the object remain unchanged. So initially the object was moving with u meter per second. So what is its initial momentum? We can calculate the value. So initial momentum, that is equals to mass multiplied by initial velocity. Now we will study about final momentum. What is final momentum? That is the product of mass multiplied by final velocity, right? Initial momentum is having the unit, that is of kilogram meter per second. Final momentum is having the unit, that is of kilogram meter per second, right? So initial momentum is having the value, that is of mass multiplied by initial velocity. Final momentum is having the value, that is of mass multiplied by final velocity. So whenever you are just applying the force, there is a change in velocity. If there is a change in velocity, so there should be a change in momentum also. According to Newton's second law of motion, it is said that if you are applying some unbalanced force to an object, there will be a change in its linear momentum. And the applied force is directly proportional with the change in momentum with respect to time. So we can mathematically express this one, that force is directly proportional to the change in momentum with respect to time. Now this expression can be elaborated. Now the force is directly proportional with If the mass can be taken common from the numerator, it can be of v minus u divided by of t. Now, do you guys remember what is the expression of acceleration? Acceleration, it is equals to change in velocity with respect to time. So at the place of v minus u by t, I can replace the value with a. So I can write down the expression. We are just proceeding to the next page. Okay. So the last line we have just written that f is proportional with mass multiplied by change in velocity with respect to time. Now, in this case, that thing that is of v minus u by of t, that thing will be substituted by acceleration. So I can write down f is directly proportional with mass multiplied by acceleration, and whenever the proportionality will be changed into equal sign, I have to introduce a constant of k. So f is equals to k multiplied by mass multiplied by acceleration. In this case, the value of k, that is of 1. So the final expression we are getting that a force equals to mass into acceleration. Now this is the mathematical expression of Newton's second law. Okay. Now we'll just study some of the numerical question based on the theoretical concept you have just learned till that time. Now if you're having any of the doubt, you just text me or you can tell me in the group. Okay, I will just make your doubt clear. Thank you so much. Keep practicing, keep learning.